Okay, so welcome to the second video for 8.2. So example. Let's express the following complex numbers in trigonometric form. So express the following complex numbers. Complex numbers. Complex numbers in trigonometric form. Okay, so number one. Let's say we have z is equal to 3 minus 3i. Okay, so what is the modulus or radius of z? So r, which is the modulus of z, it's the same as the magnitude. It's the square root of 3 squared plus quantity negative 3 squared. So the sum of the squares of the real and imaginary parts. So this is going to be the square root of 2 times 3 squareds, right? I have 3 squared, so that's 3 root 2. The angle theta, what color shall I use? Theta, of course, is inverse tangent of the imaginary part, negative 3, divided by the real part, 3. So that's inverse tangent of negative 1. So luckily, this is in quadrant 4. So this is going to be at negative pi over 4. And this is because 3 minus 3i is in quadrant 4. Okay, so we have that z, which is r, times a quantity. How do I want to say this? Orange, I think. It's going to be cosine of theta plus I sine of theta, where theta is our argument. Okay, so let's go ahead and take this down to the next line. So we have z is going to be modulus is 3 times the square root of 2 times the quantity cosine of negative pi over 2, sorry, pi over 4, rather, plus I sine of negative pi over 4. Okay, so remember that sine and cosine are odd and even functions respectively. So I can rewrite this as z is equals to 3 times the square root of 2, the modulus, times, well, cosine of a negative angle is the same as cosine of the positive angle, because cosine is an even function. And sine of a negative angle is negative sine of the angle, because sine is an odd function. Okay, there we are. So this is the trigonometric form of z. Okay, let's do another one. So subscript number 2. Let's say we have that z is equal to negative 5 root 3 plus 5i. Okay, so the radius or modulus of z is going to be the square root of quantity negative 5 squared times 3, because the square of root 3 is 3, plus 5 squared. So how many 5 squareds do I have overall? It looks like I have 4 of them. So 4 5 squareds, otherwise known as 2 times 5, or 10. So the modulus is 10. The argument, theta, will be inverse tangent of imaginary part 5 over real part negative 5 root 3. So I can call this inverse tangent of 1 over negative root 3. Now, which quadrant is negative 5 root 3 plus 5i in? It's quadrant 2. So I know that my x-coordinate is negative. So for tangent, inverse tangent, let's see if I divide each by 2. So 1 divided by 2 all over negative root 3 divided by 2. Then I'm looking for the angle that has an x-coordinate of negative root 3 over 2 and a y-coordinate of positive 1/2 in quadrant 2, and that's 5 pi over 6. So that is my argument. Okay, so my complex number z is going to be the modulus r times, let me just do this in purple, cosine of the argument theta plus I sine of the argument theta. Okay, so we found the modulus to be 10. And this is going to be cosine of, oops, said I wanted that to be in purple. So this is going to be cosine of 5 pi over 6 plus I times sine of 5 pi over 6. Okay, so that is the trigonometric form of that complex number. Okay, so I guess, yeah, that's the only two examples I did. No, I got another one here. Okay, let's do another one. Number 3. Third times a charm. So 1 plus the square root of 3 times I. So this is in quadrant 1, we know that. So the modulus r is going to be the square root of 1 squared plus root 3 squared, or 3. So the square root of 4, of course, is 2. So the modulus is 2. The argument is inverse tangent of the imaginary part over the real part, which is inverse tangent of root 3. So at what angle is it in the first quadrant is tangent root 3? That is sine is root 3 over 2, and that's going to be pi over 3. Okay, so now we know that z, our complex number, is going to be modulus 2. Actually, let me write this out. R times cosine theta plus I sine of theta Okay, so we get that z will be modulus 2. And if you get it confused and call it magnitude or length, that's fine. I know what you mean. So this will be cosine of pi over 3 plus I times sine of pi over 3. And there we are. That is the trigonometric form of this complex number. Okay, so let's go backwards. So for example, let's convert the following complex numbers to standard form or rectangular form. So convert the following complex numbers to standard / rectangular form. Okay, so number 1, let's say I give you that z is equal to 3 times the quantity cosine of 2 pi over 3 plus I times sine of 2 pi over 3. Okay, so we have that z is equals to 3 times cosine of 2 pi over 3 plus I times sine of 2 pi over 3. So we just need to evaluate. So inside the bracketed remark, let's look at, cosine of 2 pi over 3. So what is cosine in quadrant 2 with a reference angle of 60 degrees? That's negative 1/2. Plus I times sine of 2 pi over 3. So in quadrant 2, what is the y coordinate at the reference angle of 60? It's root 3 over 2. And now we can distribute the 3 inside and be done. So in one fell swoop, we have that this will be negative 3 over 2 and plus 3 root 3 over 2, root 3 over 2 times I. And there we are. This is the standard form of C. Okay, let's do another one. So number 2. Let's say we have that Z is equal to 6 times the quantity cosine of 7 pi over 6 plus I times sine of 7 pi over 6. Okay, so what do we have? I'll do this in green. So Z is equal to 6 times cosine of 7 pi over 6, which is in quadrant 3, plus I times sine of 7 pi over 6. So it's a pi over 6 reference angle in quadrant 3. So this is 6 times the quantity, let's call cosine of 7 pi over 6, 30-degree reference angle in quadrant 3, so it's going to be minus root 3 over 2 plus I times sine of pi over 6 in quadrant 3 is going to be negative 1/2. Okay, so distributing, this becomes 2 goes into 6 3 times, so this becomes minus 3 root 3. And 2 goes into 6 3 times, so this becomes minus 2 times I. Okay, so that is the standard or rectangular form for that one. And number 3. Let's say we have that Z is equal to 22 times the quantity cosine of 5 pi over 3 plus I times sine of 5 pi over 3. Okay, so we have that Z. What color shall I use this time? Let's use purple. So Z is equal to 22 times cosine of the quantity 5 pi over 3 plus I times sine of the quantity 5 pi over 3. Okay, so this gives us 22. So 5 pi over 3 is the pi over 3 reference angle in quadrant 4. So cosine is positive, and it is 1/2. Plus I. Now sine of 5 pi over 3 in quadrant 4 will be negative, and it is negative root 3 over 2. Okay, so distributing the 22 inside, we end up with 22 divided by 2 is 11. Then minus 22 divided by 2 is also 11. So 11 times the square root of 3 times I. And there we are. That's what it is in standard form. So let's see how many pages have I done for this section? Just one. Okay, I think I'll just finish this up right now. Okay, so notation. So we have that Z is equal to R times cosine theta plus I times sine theta in trigonometric form. So is sometimes annotated by Z is equals to r cis theta. I really don't like this notation, but you'll see it. Because some people like acronyms, I am not a fan. So for example, like say we have z is, I don't know, 7 times cis 3 pi over 4. That is equivalent to 7 times cosine of 3 pi over 4 plus I sine of 3 pi over 4. So if you see that notation, at least you'll know what it is. I don't use that notation. Okay, I'll see you in the next video.